Hello friends, in the last few videos we have seen how to apply Newton's second law and we have seen different cases. For example, we have seen how to apply Newton's second law when you have an object that is moving on a horizontal plane. Similarly, we have also seen how to apply Newton's second law when the object is moving on an inclined plane. Now in this video, we will see how to apply Newton's second law for uniform circular motion case. In other words, if an object is moving in a circular motion, how do you apply the Newton's second law? So the objective of this video is to learn to calculate the force in an uniform circular motion. And this we will study using a problem. So this problem says, a sled with mass of 25 kg rests on a horizontal sheet of essentially frictionless ice. So here I have a sled and the mass of this sled is given, that is 25 kg, and this rests on a horizontal sheet of ice. And it is given that this horizontal sheet of ice is a frictionless thing. So we have to assume that coefficient of friction, that is mu, is equals to 0 in this case. This means there is no friction between horizontal sheet and this sled. So there is no friction between these two. So it is moving without any kind of friction, moving freely. Furthermore, the problem says it is attached by a 5-meter rope to a post set in the ice. So there is a post in the ice. This is the post. So this sled is attached to this post by a rope and the length of this rope is given, that is 5 meters. Once given a push, the sled revolves uniformly in a circle around the post. So if you give a push to this sled, so if you apply a force or if you give a push to this sled starts moving and this will move in a circle. Something like this. So this will move, this you might have experienced. So if you have something like this and if you give a force, this starts moving in a circle, and this is uniform circular motion. So there is a uniform kind of motion. So we can apply the theory of uniform circular motion. Now if the sled makes 5 complete revolutions every minute, so this sled is making 5 complete revolutions every minute. So in 60 seconds, it revolves 5 revolutions. So we have to find the force F exerted on it by the rope. So we have to calculate the amount of force that is applied by the rope onto this sled. So what are the things that is given in this problem? So we have been given mass of sled that is equals to 25 kg. So this is 25 kg that is given. And length of rope is given, so R is equals to 5 meter. And this is also given that this is a uniform circular motion and frictionless surface. So mu is equals to 0, that is given. And we have been also given that this is a case of uniform circular motion. So this is uniform circular motion. So if we have uniform circular motion, you may remember in that case the radial acceleration is v square by r. So if something is moving in uniform circular motion, there is a 2 component. One is radial direction component of acceleration, another is tangential acceleration component. The magnitude of radial acceleration is given by v square by r. And that is important in this problem. So AR is equals to B square divided by R, that is radial direction acceleration. Now we will use this expression to calculate the forces. But before that, we have to use the fact that this makes 5 revolutions in every minute. So we have 5 revolutions in every minute, that is in 60 seconds. So we can calculate time period. So time period is the time that is required to make 1 revolution. So 5 revolutions, it takes 60 seconds. So for 1 revolution, it will take 60 seconds divided by 5, that is 12 seconds. So this is the time period. that is time required to make one revolution. Now we can apply Newton's second law. But what is the thing that we have to find? We have to calculate force. Now once I have to calculate force, then I can think I can apply force is equals to mass into acceleration. But in this case, force we have to calculate in the radial direction, because we have to calculate this force, the force in the string and in the rope, and that is basically radial direction. So mass times acceleration, and in this case acceleration will also be in the radial direction. So if I make a free body diagram, so before applying Newton's second law, we always make a free body diagram. So let us consider this axis, that is the radial direction axis, is my x-axis. So what are the forces that is acting on this slate? So this is my slate. One force is acting in the downward direction is mg, and the ground will apply a force in the upward direction, that is normal reaction. Now this will have a force due to this rope. Let's call this force is F. So there is a force in this direction, the radial direction, that is we are calling here as x direction. So we will have a force in x direction, and we will have acceleration and the radial acceleration in the radial direction. And as I said earlier, the magnitude of this acceleration is v square divided by r. Now I can apply Newton's second law, that is sum of the forces in the x direction is equals to mass into acceleration in the x direction. And in this case, the x direction is the radial direction. So in the radial direction, we have only one force, that is the force applied by the rope, that is F. And mass times acceleration, as I said, acceleration in the radial direction is v square divided by r. Now in the question, v is not given. So we can calculate v, because I know this total length is 2 pi r. And I know how much time it takes, that is capital T. So I know this takes T amount of time to make one revolution. So in this case, basically I know what is the velocity. So we can write expression for velocity, that is nothing but total distance, that is 2 pi r divided by total time, that is t. So this is the expression for velocity. Now I can plug this here, so I can write F is equals to m, and v is nothing but 2 pi r by t, and this whole square, and I also have r, so this multiplied by 1 by r. So if you calculate, this will come F is equals to m, and this is 4 pi square r square t square, and this multiplied by 1 by r. So 1 r cancels out, so we will have F is equals to m, or I can write 4 pi square r m divided by t square. So this is the force that is applied by the rope onto the sledge. So let us plug all this value to calculate the numerical values. This is 4 pi square, and radius is 5 meter, and the mass is 25 kg, and time is 12 seconds. So if you plug all this value and you calculate, this will come 34.3 Newton. So in this problem, I can say the rope is applying a force of 34.3 Newton, and by this force, this sled is moving in a uniform circular motion. One important point, if you remember, we calculated force is equals to mv square by r. So you see, in this case, if you have something attached to the rope and this is moving in a circle, so this is the circle in which it's moving. Now this force depends upon the velocity, with what velocity this is moving, and this also depend upon a radius, in which radius it is moving. This means if you increase velocity twice, the force will increase 4 times, because this is related to a square of the velocity, second power of the velocity. So if you increase velocity by 2 times, your force will increase by 4 times. Now similarly, if you basically increase the radius, by 2 times, so this is my radius, so let me write here. So if I increase my radius by twice, 2 times, force will decrease and this will also decrease by 2 times because this is in the denominator. So this is 2 times, it will decrease. So you can say force will be divided by 2 times. Similarly, you can say what will happen if you increase the velocity and also increase the radius, or you increase the velocity or decrease the radius. What will be the effect on the force that is required to move this sled in a uniform circular motion? So in this video, we have seen a small example or an elementary example that illustrates how can you calculate the force if one object is moving in a circular motion. Now you see, in this case we have not used the vertical direction equation, that is vertical direction equilibrium has not been used. If you want, you can also use that, will simply give you N is equals to mg, that is normal reaction is equals to mg. So we have only used radial direction expression that gives you the force. Only thing that you need to remember, that is the acceleration in the radial direction is v square by r, and we can calculate v using the formula that is 2 pi r by time period. So I hope you enjoyed this video, and if you enjoy, please share with your friends, and I will see you in the next video. Thank you.